So thank you very much to Ken and the rest of the Compose committee for putting this on, and thank you all for coming. It's great to be here. I don't use Twitter, so I've put the slides up on my web zone. The URL is there. You can find them, and you can find an annotated handout version as well. So what we're going to do today is we'll start with a bit of a thought experiment, then we'll talk a little bit about Reflex itself, how to make a Reflex program talk to the outside world in the sorts of ways that a native program will want to do, and we'll finish up by doing a bit of playing around with OpenGL. So imagine that you're building a program to implement the rules of a card game or a board game, and you see a card sort of like this. Now, if you attack this problem in kind of the traditional object-oriented sort of way, when this comes into play, you'll have to go through and twiddle all of the black creatures, and when it leaves play, you'll have to go through and untwiddle all of the black creatures, and then when a black creature comes into play, you have to make sure it gets its bonus, and if it leaves play, depending on how you set up your data, you might have to untwiddle it before you send it to discard. And then you think through all of these transitions and you go, all right, I've definitely got this right, ship it. And 6 months later, someone says, well, I played this card that turned your green creature black, but it didn't get the bonus. And you say, yes, of course, color changing cards are a thing. And you say, right, I've definitely got it this time. And then another 3 months after that, somebody says, well, I played this card that said change all references from one color to another. And so now the text box says all red creatures get +1/+1, and I didn't get my bonus. And you say, right, yes, of course. Changing text boxes in a printed paper game is definitely a thing that should happen. You laugh, but it happens a lot in rule systems. It's quite interesting. And so you think about, well, doing this like imperative twiddles doesn't really work. Maybe I want some sort of declarative data model to talk about how these effects stack and interact with each other. And you build up and you think, maybe someone has got a good way to talk about time-changing values and instantaneous phenomena. And the answer is, yes, that's been done. The theory is called functional reactive programming. And that's our solid theory for talking about these time-varying values and the instantaneous phenomena that cause changes. Reflex is an implementation of this theory asterisk, and that asterisk is the initial papers are quite insistent upon time being continuous, and a lot of the implementations go, but that's hard, we'll worry about it later. And Reflex builds up these networks of time-varying values and their changes through sort of two primitives and a quasi-primitive type. So the first primitive I'll talk about is a behavior of A means a time-varying A. So at every point in time, there is an A. It could be different, it could be the same, but there is always one. A value of type event A represents a collection of instantaneous occurrences of some A. Some implementations will call this observable. If you tend to think operationally, maybe that's a nicer intuition for you to hold on to. And the sort of quasi-primitive is when you glue these two things together, you get a type called dynamic of A, which is like a behavior, except it signals its updates. So if we follow time from left to right, we get this first black spot. That's the last time it has that value, and at that same time we see an event firing saying it is changing to the new value, which is the X above it, and then there's no intermediate place where it's half updated or anything like that. And so the sorts of things of like all of the modifications you might want to make to your black creatures would be a behavior or a dynamic of functions from creature to creature or something like that. And Reflex provides a bunch of these tools and functions for combining and splitting up these types and swizzling them around. But it also provides type class instances that you quite heavily have to rely on to get your work done. And so these are often a little bit hard to find because of the way the haddocks get generated. So I'll run through them quickly, but as I do so, keep in mind this idea of I want to know not just what a type class is as like a bag of function definitions, but also what does a type class mean in the sense of what problems does it help me solve? How can I use those features to solve a problem? So when I say that behavior is a functor, an applicative, and a monad, or I say that dynamic has the functor, applicative, and monad instances, then the functor means I can map, I can lift a function from points to entire time, like values over time. Applicative means I can lift a function of arbitrary number of arguments over a collection of behaviors. And monad means I have do notation, I have flattening, I have the bind functions and stuff like that. And it's about having access to these patterns of solving problems, not just the 2 or 3 functions that make up a type class definition. Event is a little bit weirder. It's a functor, but we don't even have an applicative instance because we can't come up with a sensible definition of the pure function. So as a consolation prize, here are 2 functions, 2 nice type classes from the Hackage ecosystem. Filterable generalizes this idea of map maybe and cat maybes and filter from lists to other data structures. So for event, this is like we can throw out some occurrences if we don't want to transform them. So map maybe, I can decline to handle an A and just drop it from the result. Semi-align is a type class about lining structures up next to each other. So there's an auxiliary data type called these, which is like either plus both. A these AB means it is either this A, that B, or a these of an A and a B. And so for event, a semi-align means I can take all of the firings of my first event and all the firings of my second event and line them up. And then I can talk about coincidence when I have to, and when I don't have to, I don't have to worry about it. And it's this sort of patterns that allow me to be as precise with time-varying values and state transitions as well-designed data types let me talk about corner cases in my data.
Do they have laws?
Yes, George, they have laws. We don't have time to talk about them today. So they're there, they're great, they help me sleep at night, but just trust me that they're sensible. So one of the challenges of getting into Reflex is it really does feel like a big jump. The type signatures you see in the haddocs can be pretty darn spectacular if you're not used to reading them. And when people say Reflex, they often immediately follow it with in the browser or on the front end or something like that. And this gets a little bit harder because that means you now have to start talking about compiling your Haskell to JavaScript, and to get a GHCjs toolchain often means some sort of platform to collect that and its dependencies and give you a development environment. That often means something like Nix or Obelisk on top of Reflex platform. Nix is a fantastic tool. I love it to bits, but I cannot deny that it raises the barrier of entry. If you're at all curious about that sort of thing, there's a workshop for it later today, and you should check it out because it is really cool. But today, we're going to simplify things. We're going to just straight up lie about the type signatures. Mostly we're going to drop this T here and just talk about the general shape of these type signatures to get the idea. Then when you go back to the documentation, you can sort of see through the noise and understand what you're getting at. We're going to talk about the sorts of things that native binaries want to talk about, rather than things that affect web applications. And the Reflex team are starting to get really good at getting this stuff onto Hackage, which means we don't have to use Cabal, we don't have to use Nix for everything, we can use Cabal installed directly. So a functional reactive program seems to, you get this sort of structure. The topmost box is the guest, or you might hear this called the FRP network. This is where your events and behaviors are swizzled together, and that's where the logic you write is. Reflex at the bottom layer provides a whole bunch of type classes that your program can use to do the things it needs to do. And it will also provide some monad transformers that provide implementations of those features, but the guest tends not to ask for them specifically, they ask for them by type class. And then a host library will collect a runtime, usually a production runtime like SpiderHost, or maybe a profiling runtime, assemble the exact one you need for your particular problem, and run the guest inside that. So a simple example is to talk about string input-output, sort of in the style of a standard Unixy sort of pipe kind of program. So I have standard input as an event of string. This represents every line that will ever be typed on the keyboard. And I will ask the guest to turn that into an event of string representing every line of text I want to send to standard output. And then also please provide me an event of unit that means please shut down my program, everything's finished. And I will turn that into an IO action by running all of that and feeding it inputs and responding to outputs. The problem is this is quite restrictive. If I want to open a network socket or handle files or anything like that, I still have to have my own way of performing effects or getting additional data into my FRP network. So if I'm going to do that anyway, I may as well generalize it and say, let's not elevate specific types of input and output. We will just ask for a quit event. That's the only thing we need to know at this point, and we will expect the guest to handle its own wiring into the outside world. This is what the library Reflex basic host does, which has been written and put up on GitHub from the FP lab, and its 0.2 release should come on to Hackage in the next few days. And so what we'll do now is now that I've taken away your standard input and standard output, we'll talk about recreating them. First, we'll rip through the tools that we'll need to do that, then we'll reconstruct them, and then we'll press on and have a bit more fun. So the simplest first class I want to look at is called post-build, and this is an event that says everything is built and ready to go. And Reflex is fairly advanced in that I can swap in and out chunks of a running FRP network, and post-build will guarantee that each section sees a post-build firing exactly once. So this is a nice place to hang things like kicking off a worker thread or stuff like that, but there's not really a whole much more to say about it. There's an event that fires when you're ready to go. If I want to get more data into my program, then I use the trigger event type class. So this morally is the type class for when I can create new events. So when I call new trigger event, I get given the event that I can feed to the rest of my program, and I'm given a function from A to IO unit, which is its trigger. So if I drop an A into that function, then the event fires and my FRP network can react to it. Pushing on to a little bit more complicated, we will talk about perform event, and this is how I can do actions in the outside world. So this definition here is called an associated type. It's enabled by the type family's language extension, and what it means is it's like a type alias that you have to provide when you provide your type class instance. This lets us talk about different types of actions that we can perform. So on the back end, this actions to perform event is going to be something that's a monad IO, and in our native code case, we can just get away with assuming that it's always monad IO. But then if we're running on the front end, that might be a monad that performs JavaScript actions instead of back-end database call sort of actions. But in any case, we have this event of performable actions, and then we collect them, and as they execute, we collect their results and fire off another event that the rest of the program can use to deal with their results. So we now have the tools we need to recreate standard output. There's a variant of perform event with an underscore on the end, and by convention that means I don't care about the results. So if I have an event of actions, then I don't need to bother creating the event of the results. I can just say go and do this. So here is my event of actions. Every time this event fires, it is a command that will print a line to standard output. I make that by taking the given event of strings and mapping over it with this function that turns them into IO actions. Standard input is a little bit harder because we need something to actually watch for lines as they arrive, and that means we have to work in a background thread, and to work in the background thread, we don't want to start that too early. So Reflex provides a handy function that combines trigger event and perform event into perform event async. So the trigger event side is the event is given a function that will fire off an event with any A's that it happens to discover, and it is allowed to perform actions because it's in this performable monad. So standard input, we will start by performing stuff on the post build. Post build is an event of unit, so we will replace that with our looping function. Then, to not block the entire program, we will fork off a worker thread, and then we will loop forever, reading lines from the input and firing them off into the reflex trigger so that the event that we return from this function will actually send data out. So that's standard input and standard output collected and reconstructed. We don't need to make a specific host for them. Let's now build up towards doing some OpenGL stuff. So I'm going to use fsnotify as an example because it's got nice type aliases and it's a very useful library. This watches a directory for changes using inotify or denotify or one of those sort of system level features. And what we want to get to is an event of fsnotify events, which are things that have changed on your file system. This is one of those kind of callback oriented libraries where you're expected to provide a function of things to do. And those often have a shape that looks a lot like a reflex trigger. So this parameter is an action predicate of what do we want to, are we interested in this event or not? We're just going to say, yes, we're interested in everything and rely on downstream to split out the stuff it cares about. This action, what do we do when we see an event? That looks a lot like a trigger, so we'll use that. And this IO action that it returns is a teardown thing. So when I run that, it will stop listening for changes to that directory. So this is what we have, and Reflex provides a very helpful function with an amazing name and an amazing type signature called new event with lazy trigger with onComplete. Because Reflex is able to swap chunks of the network in and out, it's also smart enough to tell whether or not an event is being listened to. And so if something starts listening to this event, then and only then will it turn on the directory watcher, and if no one's listening anymore, then it will turn it off. So we have nowhere to put the action predicate, so we're just going to say, yes, we're interested in everything. The trigger itself has grown this surprising extra parameter. It can, this is what we will do when the trigger is finished firing. We're not interested, so we'll be putting a null action in there. And this teardown is the same as the one we just talked about that watched returns. So that's those pieces, and they just pretty much click together. We're going to pass through the manager itself, which is just a bookkeeping data structure that it wants. We are going to pass through the directory to watch because we don't have any say in that. The action predicate, yes, we're interested in everything. Show us it all. And then we'll filter it downstream in our network. And this is the action that fsnotify has us run. In here is the reflex trigger, and we are not interested in doing anything in particular when it's complete, so we just put a null action in there. So what I'm going to do now is I want to build from fsnotify events to compiled OpenGL shader programs. So the simple version of the story is I want to compile a fragment shader and a vertex shader, link them into a program that runs on the GPU so that I can go and draw stuff. Every box on this slide is a reflex event of whatever type's inside. So I want to start with an event of fsnotify events and get to an event of compiled OpenGL shaders. So fsnotify events are filterable. The event type will talk about file creations, file deletions, file modifications. I'm only interested in modifications, so I can map maybe and drop all the others on the floor. I'm not interested in the modification time. I'm not interested in whether or not it's a directory. So I can just fmap that and pull out only the file path. Once I have that, I have an event of files that show changes, the names of files as they change in the directory. So I can now filter on that and just pull out the fragment shader. This is an event of file paths. If I want the contents, then I can perform event over that. There's an event of byte strings of file contents as they change. From there, I can compile those into a shader, and this is morally another perform event with a little bit of extra sort of resource management stuff to make sure I delete old ones as I compile new ones and things like that. But really it's just another call to perform event, and I get either compile errors, which are byte strings, or I get compiled shaders. And so I can split that in two using the fan either function. This is provided by Reflex, but it's basically just two that may be glued next to each other. And this whole thing is the pipeline to compile one file whenever it changes. So I can replicate it, and there's my vertex shader compilation as well. To link those is pretty much more perform events, but there's a little bit of subtlety here in that I need to make sure I have a vertex shader and a fragment shader before I try and link anything. So internally, there's going to be a couple of dynamics inside that function. So as a fragment shader compiles and comes in, I hold on to it. If a new one comes in, I throw out the old one, I hold on to that. I do the same for vertex shaders, and once I have both of them, then I can start trying to link them. And as with the compile step, I get either a byte string of link errors, or I get a compiled shader program. I can fan either that again, and then that gives me my event of compiled shader programs. And at this point I've won. These byte strings are still hanging around though, these events. And while there's no sort of compiler warnings or anything about them being unused, this is what I mean when I say Reflex does force you to think through all of the corner cases, because I can go, all right, I have these events of errors hanging around, and because I'm writing a demo program for a conference presentation, I can just send them to standard output, and that will work for me. We talked about that earlier. If you're writing a more serious program, you could send them to a development console or collect them into some larger error type with a bit more information than just byte string. But this whole structure, I find this sort of wiring diagram thinking incredibly useful for planning out how to do these kinds of programs. And this is all implemented, it's on GitHub, and you can go and read it. It's quite heavily commented. So I did, in fact, join the circus, so we are going to do a live demo, because that always goes well in conferences, right? So this is something you might recognize. This is a small interactive OpenGL program. All of the inputs have been collected into Reflex events, and the list of things to draw is just a behavior that is sampled each frame. So at every point in time, we have the list of things we would quite like to draw, and that list of things includes the vertices we want to draw, the shader program we want to draw it with, and all of that sort of thing. And behind it, I have the code for the fragment shader that's running on this. And so if I do this and swizzle the numbers around, I immediately get a FS notify event that's then split out and it says, okay, that's a new event in the, this file has changed, which means I have to recompile it, which means I have to relink the shader program, which means the list of things I want to draw changes, which means the next time I go to draw a frame, I draw it immediately with the updated everything. And so I can just play with this as much as I like, and this disproportionately amuses me. Because, yeah, it's just, reactive stuff is awesome, right? And so this gives me a really good way of tracking the flow of data through my programs. It gives me great reactivity to things that would be a little bit annoying if I didn't have like an abstraction that made them first class. And so I promised you OpenGL, and there you go, you have OpenGL. To go into all the guts of the OpenGL interface would probably be more time than I have. So I put it in the demo program, and it's reasonably well commented. And that will, if you're interested in that sort of thing, you can go and pick it up and have a look. The things I'd like you to take away, this stuff is a bit of a weird abstraction, and the easiest way to get familiar with it is to just pick it up and play with it. It's actually quite doable to learn the FRP stuff without having to deal with all of the web-shaped baggage that comes along with it, because the web can be kind of a weird platform sometimes. I think Reflex Basic Host is a great place to start, and there's a new version not very far off Hackage. I'd hoped to get it pushed out before Compose, but that didn't quite happen. And wiring diagrams, wiring diagrams, wiring diagrams. If you're going to do this, it's a great way to think about these things. And that's pretty much everything I have to say. Here's the link, some links. I built on top of an unreleased library by Ed Komet to do the OpenGL stuff. There's a library called GL on Hackage, which is an automatically generated binding of all the low-level primitives. But to go to something a bit more type-safe and a bit nicer, I liked Glow. And if a few more people play with it, then perhaps we can say, yes, it's covering everything well enough. Let's talk about getting it onto Hackage, but it's not there yet. So I might leave that up there, and depending on what Ken says, we'll take a couple of questions.